Swarms of smart drones that sniff gas leaks. New ways of air traffic management incorporating flying cars. Measuring noise and climate effects of aircraft in order to make them more sustainable. These are some examples of the work we do at the Department of Control and Operations. Let's meet some people and the labs they work in.
Welcome at the Air Traffic Control Laboratory. In this lab we can study new ways of how humans and automation can work together as a team in order to better balance the workload of a controller while at the same time increase the efficiency of the airspace in order to minimize the fuel burn of an aircraft. For example, here you can see that automation takes care of all blue aircraft while the human air traffic controller is in charge of all green aircraft. The real magic happens inside the software. So the software we have developed it ourselves, and it is also easily transportable such that we can run simulations at real air traffic control centers.
We can also study actual behaviour of human drivers or pilots in cars and aircraft. This is done in the Human-Machine Interaction Laboratory. Today, we use the left side of the lab, which is equipped with a steering wheel, and we are trying to understand the properties of the human arm in order to improve the support systems in cars and aircraft. But let's scale up. Simona is our full-motion research flight simulator that can simulate current and future vehicles, transport aircraft, spacecraft, cars, helicopters. It's used for research into simulation techniques for training and research and human-machine interaction in future vehicles. Test flight engineers can fly in radically new aircraft designs, such as the Flying V. Not only do we research about simulation to operate aircraft, but what about airports? Noise is a common problem in airports, and we have a lab that addresses just that.
Hi, I'm Bieke, and I would like to show you the acoustic camera that enables us to see sound. So what does that mean? Basically, it enables us to see where exactly a sound source is. Maybe it's the landing gear or the flaps, but how does this work? Each of those bulbs actually contains a microphone. That makes 112 microphones in total. Now, if we use all of these microphones together with the video from the optical camera that is in the center, we can accurately map a noise source. The ultimate goal of this data is in the end to use it for designing aircraft with lower noise annoyance for humans. We do that by not only looking at noise levels, but also sharpness and tonality that we perceive as more annoying.
That sounds great, Bieke. The acoustic camera can be placed anywhere. Today, it's in the Cyber Zoo. This is a test lab for flying and walking robots. Much of the research is on bio-inspired drones, like this drone that mimics the way insects fly, and on drones that work in swarms, powered by artificial intelligence. A special lab at Control and Operations is not a physical lab, but a virtual one. Right, Jost?
Yes, actually, Bluesky is a piece of software, so it's a simulation tool that we use to analyze existing or new ATM concepts, such as very dense operations over cities with drones and flying taxis. What's special about Bluesky is the fact that it's completely open source, not just a tool, but also all of the data that comes behind it. And the reason that we do that is because we want to make ATM more repeatable and more verifiable.
Thank you very much. Not only do we make use of software and simulators, we also carry out experiments in real flight. Our Cessna Citation jet aircraft is equipped as a flying lab for research into, for example, novel avionics systems, automatic flight control studies, and novel air traffic management concepts. And it's also a flying classroom where students learn all about flight performance and flight dynamics. Thanks for exploring the Control and Operations Lab with me. Want to see some more? Join me on the other lab tours too. See you there.